Dramatically increase carbon stocks in agriculture, which in Bob Zomer's data set was about 2 billion hectares in the world. Here's a list of some of the key ways in which we can pack trees usefully into agricultural systems, and which is happening in many countries around the world, particularly in the tropics. There are trees on all field and farm boundaries as one major opportunity, which is where Kenya has excelled. Fertilizer and fodder shrubs established throughout the fields, as I showed for Rwanda and Malawi and other countries where smallholder agriculture is really the thing. Then you have farmer-managed natural regeneration, a very inexpensive way of reestablishing trees across the drylands and subhumid areas of Africa and other continents. And finally, farm woodlot expansion and fruit tree portfolios in the homesteads. But let's look at how we might actually develop these stretch goals for increasing biomass carbon in agriculture using these kinds of techniques to increase profitability while we're increasing carbon storage. Well, as I mentioned earlier, current global annual increase in tree biomass carbon is probably around 200 million tons 200 million tons of carbon globally on an annual basis. We might do a stretch goal that looks at tree biomass carbon increases by 2030 of doubling that up to 400 metric tons of carbon annually. And then by 2040, 800 metric tons of carbon annually produced and stored on agricultural lands. And by 2050, doubling again to 1,600 metric tons of carbon. These are only indicative numbers, but they give us vision of how, in fact, the integration of trees can be important in this area. Now, you'll recall the 4 per thousand program that was launched also in Paris by the French government, in which they're looking at soil carbon alone and the very large increases that one may expect for soil carbon, and we should establish stretch goals decade by decade for these as well. With the right policy and the right technologies, working with farmers, this kind of change can be done, and we can look at perhaps over 2 gigatons of carbon stored annually, in addition, annually every year through these systems by 2050, and really make a difference in terms of carbon neutrality. Because, after all, we're not just talking about agriculture, we're talking about increasing carbon stocks in forest lands as well, which is 4 billion hectares in the world. Here we're protecting old-growth forests through the RED type programs and restoring degraded forests on vast areas, which can most cheaply be done by assisted natural regeneration. And finally, ways to dramatically increase carbon stocks in rangelands and permanent pastures, of which there are 3.4 billion hectares in the world. Here, the movement towards holistic grazing management system, the community conservancies, and pastoralist managed natural regeneration are key components of a scaling up vision for more holistic and sustainable rangelands with much greater carbon sequestration as well. So let me sum it all up. The big questions, as I see it, are number one, how can we develop a global partnership on EverGreening analytics to accelerate the estimation and the communication of the implications of massive scaling up practices that can increase carbon in landscapes? Number two, how can we develop national and global targets for increasing the useful carbon stocks in agricultural, forest, and rangeland? Now here, a pertinent thing is that John Dixon has proposed a follow-up workshop to this one in mid-December to drill down further on these EverGreen analytics and discussing the potential to build this kind of global partnership, which would be very exciting. He and I and a number of colleagues have also been discussing a global conference next year on the perennialization of agriculture.